Now, as you're working with consultants, you're usually going to be dealing with linked models, as opposed to all within the same model on the same network. Now, because your consultants are going to be using your model as a linked model, there are a few things to understand. Your consultants are going to be using space-based families as opposed to hosted families. These space-based families are still going to be associated with and hosted to your wall, your ceiling, your model. But, for example, one thing that it differs is if I was going to put, say, a light fixture into an architectural ceiling, in a hosted model, it will actually cut out a hole in the ceiling for that light fixture. It will align itself to the grid, that kind of thing. In a linked model, you can use alignment tools to align it to the grid, but it's going to be basically poking through the ceiling as opposed to really hosted inside of the ceiling. Now, usually that's really not an issue. It's not something you usually don't take, quantity counts of your gyp board or your ceiling tiles, so it's not really going to affect things too much. Just something to be aware of, that there are differences in the way that it works. Another thing to be aware of are MEP connectors. An MEP model cannot connect to your, for example, light fixture through a linked model. We cannot connect it to show it on our panel schedules, to show it on our schedules, to get the power flowing, same thing with the mechanical equipment. So if the architect chooses to lay out the light fixtures, what's happened in the past is that you can go in there, you're basically going to have to copy all those and then paste them into your model or place one on top of each of theirs. And as you get updates, you have to kind of move them around to make them work, because you're going to have them in your model to be able to link to them. Now, in 2011, Revit has introduced copy monitoring for MEP systems. You might be familiar with copy monitoring, but basically what happens is I can choose to copy all the light fixtures in an architectural model, and then the monitoring part is that if you move it in your model, when I get an update, it's going to move it in my model. They're linked. And so now I can have linked things that move with each other, but I can now connect to them. I can see how their load affects the building load. I can use the MEP systems, such as hydronic piping, airflow, power, switching, those kind of systems that MEP needs. I can now use those with an architectural model. Now, there are some drawbacks and limitations to copy monitoring, so sometimes it will be used on some portions and not others, and it's project specific. So if we're working on a project, we might tell you what we're going to be copy monitoring and what we're not going to, just so that you're aware. And that's something we can talk about on a particular project. Another thing that is often overlooked is MEP work sets are used very differently than architectural work sets. A work set is designed to be able to split up the work. I can, say, assign the first level of a building to a work set, and then I can check it out so that only I can work on it right now, and no one else can modify that until I check it back in, and then they can check it out, etc. Well, with MEP, those work sets are actually used for filtering sometimes, where, for example, if I'm an electrical engineer, which I am, and I want to show mechanical equipment on my electrical plans, I can check the box of visibility graphics and say, show mechanical equipment. All of a sudden, I have a huge mess of mechanical stuff all over my plan. Well, what I probably want to do is just show the mechanical equipment with electrical connectors. Well, Revit doesn't allow you to do that, so what we do is we split it up into work sets, and then I can turn things on and off however I want. Okay, I know you guys don't care about that, but how it affects you is that when we send you a model to coordinate, you're looking at a view, you're using the visibility graphics, and you turn on mechanical equipment, and you're saying, wait, there's stuff missing, they didn't finish. Then you go to another view, and you're like, wait, I can see it here, but I can't see it here, but I've got the exact same visibility graphic settings set in both. What's going on? Well, there's a hidden layer of this work set visibility that you have no control over. Now, Revit 2011 has added the ability to take control of that now. So it's something to be aware of. Now, what we do is, as a company, we have a button that we've programmed using the API where it'll merge all the work sets to a common work set, so that when we send it out to clients, they'll be able to see the entire picture when they're looking at any view. They can use the default Revit visibility settings to check things on and off and be able to use it how Revit intended them to do it. So it's just something to be aware of. If you're dealing with consultants and you're seeing things on one view and not another, it could be caused by the work sets. And starting in 2011, you can now look at the work sets and turn them on and off. But before that, you were just lost and had no way to control it. On to analyzing the model. This goes back to the idea that when you buy Revit out of the box, you look at all the marketing material and it's just great. I mean, wow, this thing is going to be able to do not only my building design for me, but now it's going to do my solar calculations, my shading, my photometrics. It's going to do my energy calcs. Wow, this thing is amazing.
Just push a button and go to the beach.
That's right. You know, let's go. Well, until you try to push that button and you can't find it, or you push the button and something else pops out. Well, what we find is that in general, we're still having to go back to tried and true methods, tried and true software that has been developed in the industry to do some of these things. Down here on the bottom, there's a list of some of the software that, or some of the simulations that you would want to do in a model, and on the right are some of the software tools that are used to accomplish those. And so, the next few slides, we're going to show you Revit working with some of these software. So you still want to use the Revit model. You don't want to have to remodel all of this information in every piece of software. So this particular slide is interesting because it's a case study where we actually worked with an architect and we said, all right, architect, build us 3 buildings, and they're just simplified. These aren't real buildings, but we want them to be, a little bit varied in their shape. We want to have, a little bit of variance so we can see how this works. And then what we're going to do is we're going to do energy modeling on all of them. They all have similar square footage as far as the building makeup. But we want to see, one, how the different shapes of the building affect things, but also we want to see how the modeling tools can interact with the simulation tools. So this first section on the bottom there is when we took that model and we exported it to Green Building Studio, which will do energy calculations for you. Again, it's a software that Autodesk purchased and has kind of been putting into its arsenal. So we put in the model, we calculate the numbers, and we've got the numbers that pop out. We've got our total energy usage. Man, this is great, we're all done. Let's put it on our lead calculation reports and let's move on. Well, what we ended up doing is we looked into that Green Building Studio model and we noticed there were windows missing, there were ceilings missing, there were interior spaces that were being treated as exterior spaces. There was air escaping through cracks in the corners of the building. There was all sorts of funny things happening, and so we went back and we analyzed that compared to our Revit model, and we went in and we corrected the Revit model. When I say corrected, I say we wanted to make it the way that Green Building Studio wanted it to be imported. And so we corrected the model, and some of the lessons learned from that are, again, in your quick reference guide there. It's under the section Maintaining GBXML Connectivity, so you can learn how to model something up front from the beginning to be able to export to some of these tools without too many glitches. So we went in and we corrected the model, re-exported the Green Building Studio, and then we get the second section here of our corrected model. So great, we've got a new set of numbers, which of course are different from the first set of numbers, but we feel a lot better with this because now we don't have our ceilings missing, we don't have things leaking out the side of the building. But we went a step further. We went and we took the DO2 file, the energy modeling file that's used in the background for calculating stuff, and we stuck it into eQuest, which is another software that uses actually the same DO2 engine as PBS, but it gives you a lot more control over things. Green Building Studio makes a lot of assumptions for you, and you don't have control to change them. It makes assumptions about your plumbing systems, your mechanical systems, your electrical systems. In eQuest, what we did is we went ahead and not only is the building modeled accurately, but now we took all of those assumptions and we modeled the mechanical and electrical and plumbing systems the way that they really are going to be installed. And then we came up with another set of numbers. What we need to understand from this slide is that just because you click a button and you get numbers out, if you don't understand where those numbers came from and what assumptions were made, you're just guessing at the accuracy of that number. And it may or may not be good enough to get you by, LEED or any other thing, but it's definitely not going to be accurate to the level that you want it. This slide is just showing you that you can take that Revit model and export it to Ecotech to do solar analysis, and that can be used for figuring out the shading, how it's going to shade different things for your heating and cooling loads throughout the year, what the best orientation of the building would be, or whether you want to figure out daylight autonomy. And this slide is also from Ecotech, showing you how you can do renderings of how the solar radiation is going to be entering into the building. Now, CFD analysis, which is computational fluid dynamics, is very, very computationally complicated. There's so many computations that have to happen to be able to produce these calculations. We're talking about airflow, how airflow mixes in a space, how the temperature is controlled not only in the room but throughout the entire space. You're figuring out where things are going and how fast things are moving. And there's so many calculations that have to go on that it's very rarely or never that you will use a Revit model in a CFD program. That being said, it's still very important to be able to have a Revit model because it's a 3D representation where you can see exactly what's in the space, what obstructions are going to cause the most problem, and you'll be able to model things a little bit better in the program. You'll notice on the bottom left that the man is just blocks. I mean, he's just made out of big blocks. You've got filing cabinets, just basic geometry that's going to be used to determine how things are going to go in the space. The bottom right pictures here were actually for a pharmaceutical storage facility, where it is very important for them to figure out what the temperature was going to be, again, not only for the entire space, but they wanted to make sure that they didn't have any hot spots, that they weren't going to have any spaces where product being stored was going to go bad or spoil. And the top one, red is hot, green is cool. You'll notice that in these two different air distribution methods, we were able to see that one method was very ineffective, while the other method was very effective. That's determined by the type of air distribution where you're locating the diffusers. It's also determined by the airspeed and the temperature that you're putting into there. So what that shows you is it's very important to be able to make an informed decision on this kind of stuff. And if you're not modeling it, then you're just taking a guess as to how well your building is actually going to be able to perform. Photometric analysis, this is figuring out where light goes and how it's going to look, and also how much light is going to be on the surface. The upper left picture was one that we did in Revit. Revit has a photometrically accurate rendering engine, but it's going to give you a visual representation of the space as opposed to photometric point-by-point calculations that engineers need to use to be able to determine if we have enough light on a table or in a space to do a specific task. For that, you need to use AGI 32 or another software that does the same thing to create those point-by-point photometrics. The upper right picture is a rendering done in AGI 32 that was exported from a Revit model. So we're able to use the same model, export it to AGI 32, but now we're able to get those engineering calculations that we care about, that you obviously, you don't care as much about. You care about what it looks like. The bottom right photometric, this was done in AGI 32. It was imported from a 3D DWG file that was actually exported from 3D Studio Max as opposed to Revit. But it shows you that you can use that 3D model, that same 3D model that you're using for your building construction in these other programs. And that was part of a lead study to make sure that there was not any light pollution off of the site. All right, and the last section that we're going to talk about is programming add-ins for Revit. How to extend the capabilities of Revit just a step further. Now, API stands for Application Programming Interface. And what it gives you is it gives you access to the inputs and the outputs of Revit. What that means is you'll be able to read and write parameter values. You'll be able to create geometry and families automatically. You'll be able to automate repetitive tasks. And then you can also handle events like, I want you to do this action before somebody saves, or as somebody saves, or just after they save. Or every time a new document is open, I want you to perform this task or check this thing. These are just some screenshots of some of the examples. The top screenshot shows the toolbar as it appears in Revit. It's going to appear on the add-ins toolbar where you can add in your own buttons and icons and have it open up, programs or different types of things. And the next slide is going to be a little bit better introduction as to what's available and what these particular software things do.